Hi everyone, welcome back to Awesome Math. Today we're going to be covering SpringBoard Course 3, Lesson 12.1 on page 159 of your textbooks. I'll repeat that again, page 159 of your textbooks. So this activity generally has to do with equations in point-slope form. So, in slope-intercept form, I'm very sorry, in slope-intercept form. So without any further ado, let's just get started. So before we start talking about slope-intercept lines in slope-intercept form, we have to understand what are the slope and the intercept. So let's start out with problem 1, which will help us dive into the slope specifically. So they say that we have the equation y is equal to minus 3x plus 24. They don't give a, and this is representing the water leaking from his bottle. So let's just quickly draw a bottle. So let's suppose that this is his bottle, and they don't give units. I'm just going to assume it's centimeters here. So let's suppose that there is a hole in his bottle and water is coming out of it. All right. So the thing is that all the water won't come out at once, right? Because the hole is very small. Imagine the hole is much smaller than as I drew it. So if the hole is very small, all the water won't come out at once. So what he's done here is he's basically written an equation to represent how much water has fallen out of his bottle as time progresses. So basically at the time x, so if x is say 1 second or 5 seconds or 10 seconds, then we can figure out the height of the water y. That's the idea of this. So x is time since hole came, maybe like when we accidentally dropped the bottle or something, and y is just the height of the water in bottle. So that's what we're trying to represent here. And now what they're saying is, what is the slope? And what does it represent in this problem situation? Be sure to include units. So, well, the question is, what is the slope? Well, the slope is a pretty simple concept. The slope, this is important, slope is, so the slope, we use it to represent the change in y. We use it to represent the change in y as x changes. So if we see here in this equation, if we plug in x, if we plug 1 for x, then we'll get an answer. And if we plug in 2 for x, then we'll get something for y. If we plug in 1 for x, we'll get a y. And if we plug in 2 for x, we'll get a different y. So the idea is we can use slope to represent change in y as x changes. And so the question is, well, that's like what it's meant to do. What does it do? Well, slope asks the question, how much does y change when x increases by 1? So how much does y change when x increases by 1? So let's think about this. So, okay. Well, so let's try out what we said earlier. So let's say, I'm going to delete some stuff now. If you guys need them, you can refer back in the video. Just quickly wiping this stuff so that we have more. I still want the equation. So now what we have is we have y is equal to minus 3x plus 24. Well, let's see, how much does y change when x increases by 1? So let's just try pretty much any, any x. So let's say x is equal to 1. Well, then what's y going to be? Y is a pretty simple thing here. Y just represents, y is just going to be minus 3 times x. X is 1 plus 24. So then y is just going to be equal to 21. That's not that hard. Let's do it again. Minus 3 times 2 plus 24 is equal to minus 3 times 2 plus 24 is equal to, well, that's just 18. So now we have these two. So now you might be saying, all right, now what we do is we just subtract the first y we got with the second y and then we're done, right? But I want to give you guys a more general equation because because we know we want what happened if x increased by 1, but suppose what would happen if we didn't have this equation. Suppose we didn't have this equation, and instead we were just given the coordinates for the point at x equals 1 and the point at x equals 3. Oh no, what do we do? The difference between 1 and 3 isn't 1, so what do we do with that? Well, don't mind the hypothetical scenario and just understand. If you didn't understand the hypothetical scenario, that's fine. Just make sure you guys understand this equation. So what I'm going to say is the slope, and from here on the slope will be referred to as m, because that's convention. The slope m is going to be equal to y1 minus, or actually most textbooks say y2 minus y1 over x2 minus x1. And you guys might be wondering, wait, what's this 2 and 1 business? Well, the 2 and 1, the 2 and 1 just represent any specific point. So represent the x and y of any specific coordinate. So these have to be the same coordinate. And these have to be the same coordinate. All right. So we know that that has to be the same coordinate, and we know so does that one. So we know that x2 and y2 are from the same coordinate, and if I said something, don't mind what I said in the last 30 seconds. X2 and y2 are of the same coordinate, and x1 and y1 are of the same coordinate. So how we would get x2 and y2 is we would say pretty much any x can be x2, and then we would find its respective y by plugging into the equation, or it's given to us, and that's our y2. And for x1, we do the exact same thing. So let's now use this equation here. So what I'm going to say is I'm going to say that, and basically the 2 just denotes that it's of the second coordinate, and the 1 just denotes it's of the first coordinate. So I'm going to say that our first coordinate here is going to be 1, 21, and then our second coordinate is going to be 2, 18. So let's plug numbers into this equation. So what's y2? Y2 is the y of our second coordinate, so 18, minus and now y1, the y of our first coordinate. If I can find my mouse, 21. Next, well, we want the x of the second coordinate. Well, that's 2 minus the x of the first coordinate, which is 1. And you can choose any 2 coordinates. And we have the x of the second coordinate, which is 2, and the x of the first coordinate, which is 1. Now we just do minus 3 over 1 is equal to minus 3. And that's our answer. So now let's do a bit of conceptual review. So the slope just represents how much will y change as x increases by 1? And that's what we found out here. And this formula works, you can use it, don't worry about it. And then also, an important thing is that one thing is, what does the slope mean when it comes to a graph? Which is the next thing I'll explain. So what a slope represents is essentially the steepness. So for example, well, suppose I have this line in green. All right, it has a specific steepness, right? But suppose I'm saying, hey, I want a line that's a bit less steep. That's a bit too steep for me. Well, then we can say a line like the blue line. And the point is that the slope represents the steepness. So we can say that the green line has a high slope, and then we can say this blue one has a lower slope. It's smaller in comparison, right? So that's that. So we have the high slope and the low. So that's kind of what the slope means in terms of a graph. It just represents what is the steepness of our graph. How steep is the line, basically. So that's what slope means when it comes to that. Next question. So the next thing is, well, we figured out the slope. What does it represent in the problem situation? Be sure to include units. Well, we figured out our slope to be -3. And so if we know our slope to be -3, well, what does that mean? Well, what that means is, so they don't tell us the units, but I'm going to assume the units are, just assume the units are something reasonable if they don't give it to you or ask your teacher. I'm going to assume that x is in seconds, so how many seconds have passed, and then since the hole was created, and y is just centimeters, how high is the water level. So I'm going to say, so slope means every second that passes, the water level. So what that means is that for every second that passes, the water level, and you might be, and then what you might be prompted to say is you might say the water level increases by then our slope. But the thing is that here, don't forget, so generally, if the slope is positive, then you would say the thing increases by that unit. But if it's negative, like we have here, then we want to say the water level does not increase, because it's not increasing, it's decreasing. Because if you have a negative slope, that means that your y is decreasing. And if you have a positive slope, your y is increasing. And the water level decreases by 3 centimeters. That's the explanation. And there's one more thing that I want to explain, which is, you guys might wonder, hey, we got -3 here, but isn't -3 also the number we're given here in the equation? And you would be completely correct. It is the number we're given. So the question is, what's the relation? Well, the thing is that if you have an equation of this format, which we'll go into more depth later because this is slope-intercept form, whichever number is the coefficient of the x, that's always going to be your slope. I'll repeat that again. Whichever number of the coefficient is the coefficient of the x, that's your slope. All right, so that's how you do number 1. And there's one more thing I wanted to go over with regards to slope, which is that there's a bit more I wanted to go over when it comes to the steepness analogy. So as I was saying, positive slopes mean you're increasing, so it would be a line like this, because here you kind of see that you have a slope that as x increases, so does y increase. But what happens if you have a negative slope? Well, a negative slope, you would have a line like the red line, where as x increases, y is decreasing. And then you might be wondering, hey, what happens if I have a zero slope? good question. So if you have a zero slope, then that just means that, or maybe this isn't the best place to draw it. As x increases, y stays exactly the same. There's no difference. It doesn't change at all. So I'll just write it out. So this is negative slope, positive slope, and then this is zero slope. I know it doesn't look like zero slope, but just assume it's a flat line. So yeah, zero slopes always have flat lines. Positive slopes are always going upwards, and negative slopes are always going downwards as x increases. So that's how you do number 1. Let's move on to the next problem where we covered the second important point. So we covered slope. That's what we just spent like a lot of time going over. Let's go to the next one, which is also very important, which is the y-intercept. What is the y-intercept? So let's rewrite your equation. What is the y-intercept and what does it represent in this problem situation? Be sure to include units. Well, the y-intercept, it's pretty simple. Just suppose we have a graph, right? And suppose I have like some equation. Suppose I have a graph like this, right? Or let me redraw it to make it a bit better. Suppose I have a graph like this, right? So the y-intercept, it sounds quite intuitive. The y-intercept is y-int. I'm just writing int here for short for intercept. The point where the graph, the line intersects the y-axis. The point where the line intersects the y-axis. That's the y-intercept. So for example, in this line that I just drew, it would be here. And suppose I drew another line, maybe this one. Well, then the y-intercept would be here, at this point right here, right? So, so basically the point where the line intersects the y-axis. So one thing you guys might be realizing is that, hey, if we have if the point line intersects the y-axis, the x is always 0. So don't we just want 0 and then some y? Isn't that always the y-axis? And you would be correct. Because the thing is that the y-axis is all values of y given that it's all coordinates such that x is equal to 0, right? Because if you look at the graph, x is always 0 on that vertical black line because that's the y-axis. So what that means, and if we have an equation that crosses the y-axis, then that would just mean that its y-intercept is just the point where x is equal to 0. So what we want is so we can also I'm going to rewrite this in a sense that's more useful to us, which is that the point where x equals 0. So the thing is that, well, amusingly enough, we already know what x is. It's 0. But we need to know y. So how do we figure that out? Well, y, we are just going to say -3 times 0 plus 24 because I'm saying x is 0. And then y is equal to 24. So now, because this cancels because x is 0, we get y is 24. And now, because of that, our y-intercept is 0, 24. And sometimes your teachers might want you to just write 24. I would talk to them about it, because the thing with the y-intercept is you don't care about the x-coordinate because you always know it's 0. But the y-coordinate is what we want here. So I would ask your teacher as to whether they would want you to do the whole point or just the coordinate. So I mean, whether they want the coordinates or just the whole like point, or they just want the y coordinate. I would talk to them about it. But yeah, so now let's kind of let's do the second part of the problem, which is what does it represent? Well, to explain what it represents, let's think about it. What are we saying? Well, we're talking about the point where x is equal to 0. Well, what is x? Well, we said x is the time. X is the number of seconds since the hole was created. So we know. So if x is equal to 0, what does that mean? Well, that must mean that it's the amount of water that was in it's the water level of the water. It represents the water level when the the immediate second where the hole was made. So no water had the chance to come out yet, but this is when our equation starts. So that's the answer. I'll write this in blue. In this case, since we're doing like a real life application, it makes more sense to use only the y coordinate here. So, but I'll just write the intercept is 0, 24. It represents that the water level was 24 centimeters when the hole was made. So that's what it means. And so basically what it represents, it just represents, okay, what does it mean for x to be equal to 0? And then what does it mean for y to be a specific value then? So what it means here is that when the hole was made, immediately when the hole was made, before any water had flown out, the water level is 24 centimeters. So it's pretty safe to assume that even before the hole was made, the water level is 24 centimeters. We started with the water level of 24 centimeters that then reduced because the hole was made. All right. So we have the intercept being that. So we know that the intercept is 0, 24. It represents the water level being 24 centimeters when the hole was made. And one thing that you guys might have noticed is that, hey, we got 20. We don't care about the x coordinate because we always know it'll be 0. But the y coordinate, isn't that just the same that we got here? Is that a coincidence? And the answer is no, it's not coincidence. If you have, this will become a lot more relevant later in later sections, but if you have a point like, if you have an equation like this one, where you have y is equal to something times x plus something, well, the y coordinate of the y-intercept is always going to be the constant that x is added to. So you have this minus 3x bit, so you have minus 3, so you have 3x, you have x and its coefficient, and then you have something added to that. That something added to that is always going to be the intercept of the y-intercept. I'll repeat that. It will always be the y coordinate of the y-intercept, and that's the constant. So we have the coefficient, which is the slope, the minus 3, and then we have the constant, the 24, which is the y coordinate of the y-intercept. So minus 3 is the slope, 24 is the y-intercept. 24 is the y coordinate of the y-intercept. Don't make that confusion. All right, so there we go. That's number 2. So now let's look at number 3. So Owen's wondering what would happen for the model of the slope to change to -4. Well, we already have it at -3 because we figured that out. Now we want to know how can we make it -4. Well, what does it mean if it's -4? Well, what it means is that right now, if every second the water level decreases by 3 centimeters, well, for it to decrease 4 centimeters every second, because if it had a slope of -4, that would mean the slope would decrease 4 centimeters every second. That's what a slope of -4 would mean. Don't mind what I just said. A slope of -3 means that that the water level decreases 3 centimeters every second. A slope of -4 means that the water level decreases 4 centimeters every second. So that would mean that more water is coming out because instead of decreasing instead of the water level going down 3 centimeters per second, now it's going down 4 centimeters per second. So that means more water is coming out. Well, how do we get more water to come out? Well, there are probably multiple ways you can do this, but an easy one is just to say bigger hole. If you increase the size of the hole a certain amount, then you would probably have 4 centimeters. You would probably have the height of the bottle's water level decrease by 4 centimeters per second. The height of the bottle's water level will decrease 4 centimeters per second if you get a bigger hole. All right. I'm sorry. And now I won't do any of these last couple problems. I'll just guide you through them. So I'll help you out with some of them. So let's look at 4. So 4 says, line with the slope of 3. So we have m is 3. Don't forget m means slope. Goes through the point minus. Oh, and one more thing that I forgot to mention. The y-coordinate of y-intercept is represented by b. It's just represented by lowercase b. Don't forget that. And the slope is represented by, and the slope of a line is represented by m. All right, let's now get to the problem. So we have m is equal to 3. So, well, if we remember how our equations were earlier, we had y being equal to x times m times x, because m is the slope, and we noticed that the coefficient of x is always the slope, plus b, and b is y-coordinate of y-intercept. Y-coordinate of y-intercept. So, well, let's look at this. So what they're saying is that, well, we have m is going to be equal to 3, so we have y is equal to 3 times x plus b, and they also give us that there's another point, 3, 5. Well, we want to figure out what b is, so why don't we plug in our x and y? So we have 3 times 3 plus b is equal to 5. Well, 5 minus 9, because 3 times 3 is 9, is equal to b, and we just subtract 9 from both sides. Minus 4 is equal to b. Well, then we know b is 4. B is minus 4, which means that y is equal. The y-coordinate of our y-intercept is going to be -4. So, I mean, if you looked at this on a graph, then the y-intercept will be somewhere there, just to kind of explain it to you guys. But if you still don't get it, but I would also rewatch the video or look at other resources. But yeah. So now we have y is just. So now we have y is going to be equal to. Well, now we have equals mx plus b, if we have it there. So we have 3 times x, and then b is minus 4. So we just say plus minus 4, or we can rewrite that as y is equal to 3x minus 4. All right. And that's how you get your equation. And now we can finally go to the end of the problem, where we're just like, how do we go, what's the value of p? Well, what they say is that there's a point minus 2p. So, well, we can just do the same thing. We can, as we did earlier, we can plug in our x and y. So we know that y is p, and we know that x is just going to be -2. So p is going to be 3 times -2 minus 4 is going to be equal to -6 minus 4 is equal to -10. And that's it. That's all there is to it. 5 is very much a similar problem, and 6 is using the slope. You just have to use the equation I gave you at the start of the lesson, and that's pretty much it. That's all I have time for right now. Thank you very much, and I hope you have an amazing day. Bye.